In this video, you will learn how to find the location of a point after rotation of axes. Begin by graphing the ellipse given with the formula lower x squared over 9 plus lower y squared over 1 equals 1. Now, imagine rotating the ellipse 45 degrees counterclockwise, which gives us a conic section with a graph that is not aligned with the lower x or lower y axis. The equation 5 lower x squared minus 8 lower x lower y plus 5 lower y squared minus 9 equals 0 represents this ellipse. A new coordinate system could be introduced with the same origin, but the lower xy coordinate system is also rotated 45 degrees counterclockwise. In this coordinate system, the rotated ellipse has a major axis on the new capital X axis and minor axis on the new capital Y axis. We can now develop the rotation of axes formulas, which allow us to transform the second-degree equation in lower x lower y into an equation in the new capital X capital Y system of a conic that is familiar to us. We will use the generalized equation a lower x squared plus b lower x lower y plus c lower y squared plus d lower x plus e lower y plus f equals 0. Let the new capital XY coordinate system be a rotation of the lower XY coordinate system about the origin by angle theta. Let P equal some point at a distance r from the origin. We can represent the point P as the point lower xy on the original coordinate system or capital XY on the new coordinate system. Next, we will define angle alpha as the angle that r makes with the new capital X axis, which means that alpha plus theta is the angle that r makes with the original lower x-axis. We can now represent point P in polar coordinates using the following relationships. Lower x equals r times cosine of the quantity alpha plus theta, lower y equals r times sine of the quantity alpha plus theta, capital X equals r times the cosine of alpha, and capital Y equals r times the sine of alpha. Now, we can derive the rotation of axes formulas. We will start with the lower x term and write the cosine identity for a sum. So, we have lower x equals r times the cosine of the quantity alpha plus theta, which equals r times the quantity cosine of alpha times cosine of theta minus sine of alpha times sine of theta. Next, eliminate the parentheses and group r with the alpha terms. So, lower x equals the quantity r times cosine of alpha times cosine of theta minus the quantity r times sine of alpha times sine of theta. Then, substitute according to the relationships. Capital X equals r times cosine of alpha and capital Y equals r times sine of alpha. This gives us the rotation of axes formula for lower x. So, lower x equals capital X times cosine of theta minus capital Y times sine of theta. We can then duplicate this process for the lower y term. Begin by using the sine identity for a sum. We have lower y equals r times sine of the quantity alpha plus theta, which equals r times the quantity sine of alpha times cosine of theta, plus cosine of alpha times sine of theta. Next, eliminate parentheses and group r with the alpha terms. So, lower y equals the quantity r times sine of alpha times cosine of theta, plus the quantity r times cosine of alpha times sine of theta. Then, substitute according to the relationships as before to get lower y equals capital Y times cosine of theta plus capital X times sine of theta. Suppose that the lower x and lower y axes in the rectangular coordinate plane are rotated through an acute angle theta to produce the capital X and capital Y axes. We can solve for capital X and capital Y in terms of lower x and lower y, and doing so tells us that the coordinates lower xy and capital XY are related according to the following equations. Lower x equals capital X times cosine of theta minus capital Y times sine of theta, and lower y equals capital X times sine of theta plus capital Y times cosine of theta. Or, capital X equals lower x times cosine of theta plus lower y times sine of theta, and capital Y equals negative lower x times sine of theta plus lower y times cosine of theta. Now, let's try an example. If the lower xy axes are rotated 30 degrees, find the capital XY coordinates of the point lower xy equals 2, 3. Starting with the rotation formulas, let lower x equal 2, lower y equal 3, and theta equal 30 degrees. So, we have capital X equals 2 times cosine of 30 degrees plus 3 times sine of 30 degrees, and capital Y equals negative 2 times sine of 30 degrees plus 3 times cosine of 30 degrees. Since cosine of 30 degrees equals the square root of 3 over 2, and sine of 30 degrees equals 1/2, these equations simplify to capital X equals the square root of 3 plus 3/2, and capital Y equals negative 1 plus the quantity 3 times the square root of 3 over 2. Therefore, the capital XY coordinates are the square root of 3 plus 3/2, negative 1 plus the quantity 3 times the square root of 3 over 2.